Welcome back to my channel. In this video, we will be talking about responses to hazards. A natural event refers to any natural process which occurs on the earth. These natural events result in both positive as well as negative consequences. People live in areas where natural events occur. In order to benefit from the natural events, as well as to use the space. As a result of people settling in areas prone to natural events, they are also exposed to the negative impacts of these events as well. When we consider the negative impacts of natural events, then we can talk about natural hazards and natural disasters. A natural hazard refers to the threat of a natural event to lives and property. A disaster is the realization of a hazard. That is, it is a negative impact of natural events on people's lives and their properties. So, for example, if a landslide occurs along a slope, as shown in the animation, vehicles passing adjacent to the slope will be exposed to that landslide. Whether this is just a hazard or it becomes a disaster will be dependent on the time factor, for example. So on the left, the vehicle arrives minutes after the landslide has occurred, so the event remains just a threat, but has not been realized, so it's not a disaster. However, on the right, we see that the landslide occurs just as the vehicle is passing, which results in the car being hit by the material. This makes it a disaster since the threat has been realized. The natural events we study based on the CAPE syllabus are flooding, volcanic eruption, and earthquakes. Flooding refers to the process by which land, which is normally dry, becomes inundated with water. It is caused by precipitation events, drainage basin characteristics, sea level rise, as well as human activities, and may result in erosion. Volcanic eruptions occur when a variety of volcanic materials are ejected from a vent or fissure onto the surface. The result is a wide variety of hazards such as lava flow, pyroclastic flow, ashfall, tsunami, and so on. Earthquakes occur when energy which was previously stored up along a fault is suddenly released, resulting in the shaking of the earth. This shaking can cause fires, landslides, tsunamis, liquefaction, and so on. Flooding is the most common type of hazard since it can result from many different sources. Earthquake is the most sudden and is therefore most difficult to predict. Volcanic eruption is the most dramatic, manifesting itself in a variety of forms. Hazards and disasters are not just the result of a natural event occurring, but is more so the result of these events occurring where people are exposed to them. Thus, the characteristics of the event as well as the nature of the human society are important to determine the level of impact. Natural events may be described based on the speed of onset, the magnitude of the event, the duration, the frequency, and so on. And so these elements or attributes of the events are will determine the level of impact. The nature of the human society includes the level of exposure to and experience of the event, the level of development of the society, the population size, as well as the population density. Generally speaking, more developed countries are usually more equipped to deal with natural events than less developed countries. Since people have to live where extreme events occur, it is vital that they develop ways of predicting when these events will occur so that they can make adjustments to the human systems to minimize their vulnerability. When notice of an impending disaster can be issued well in advance, people can act to protect themselves from injury and death. Predictions and warnings can also reduce damage and economic losses. Let us examine the methods by which natural events are predicted. Flooding within a drainage basin often forms when heavy rain falls and the ground stops soaking up that rain. To predict a flash flood, forecasters need to know how much rain is falling and how much moisture the ground already contains. If the soil is already saturated from previous rains, the lag time for the water to get to the river will be short and the water will rise quickly, causing flooding. To predict floods, precipitation and river discharge are measured and monitored by gauges. Real-time precipitation data are used to forecast water depth above a certain reference elevation or datum known as a stage. Discharge is the total volume of water that flows past a point in a river for some period of time. These two variables are measured at a point along the river called a gauging station. Automated equipment are used at a gauging station to continuously monitor river stage and river discharge. Unfortunately, these equipment are expensive and can only be set up in limited places. Another method is where satellite sensors can be used to, to observe the long wave radiation emitted by the soil. The sensor can detect differences in microwave radiation being emitted by soil depending on how moist it is. From the satellite, dry grounds appear warm with more microwave emission, and wet grounds appear cool with less microwave emission. The satellite sensors have the additional advantage of being able to observe changes in moisture levels over a large geographic area. The data obtained from satellite images can in turn be used to create hydrodynamic models to decrease forecast uncertainty. Mathematical models are developed to show how rivers and streams would react to rainfall and snowmelt. These are developed from selected points of the river or urban areas with a history of flooding. When heavy rains are forecasted, the amounts are entered and the model estimates the resulting stage and discharge. Now, let's examine how volcanic eruptions can be predicted. Like floods, volcanoes can be monitored from space by orbiting satellites. Satellites provide information from special sensors that can detect heat, sulfur dioxide, and even tiny changes in the shape of the Earth's surface. All of this information can offer clues as to whether an earthquake is imminent. Sorry, an eruption is imminent. Volcanic eruptions are closely related to the seismic activities that also cause earthquakes. A violent seismic reading is often a precursor to an eruption when it occurs near a volcano. Seismographs can be used to detect seismic activities. Changes in the landscape and deformations at ground level are often predictors of volcanic activity. Magma movements beneath the ground can cause visible bulging and hollows to form. These changes offer clues about volcanic activity under the ground. Tilt meters are instruments similar to spirit levels in that they have a small container of liquid which shows how much the ground moves. The tilt meters are connected to computers that monitor ongoing changes in the landscape. Hydrology is the study of water flows and groundwater. Hydrologists use pressure sensors, water detectors, maps, and the naked eye to gather data. Measuring the surface and groundwater flows on volcanoes can provide clues about the activity of a volcano. A sudden change could predict a volcanic eruption. The paths that water takes as it flows down a volcano's side can help us understand how lava might flow. This in turn helps scientists to determine where and when to evacuate if an eruption occurs. Volcanoes emit gases, so measuring gas emissions around volcanoes can also provide useful information about changes in behavior that could indicate an eruption in the making. The instrument used to do this are typically trapping bottles, wherein local air is pumped into the containers and then analyzed in a lab. As magma moves towards the surface of the earth, the pressure releases gas. The two most abundant gases are sulfur dioxide and carbon dioxide. And if levels of these gases increase, it shows that magma is rising to the surface and an eruption is more likely. By far, earthquakes are the most difficult hazards to predict. Prediction involves knowing three factors: the time, the place, and the magnitude of an upcoming event. Seismologists have had some success with predicting locations and intensities of earthquakes, but the time factor has proved elusive. As such, scientists use earthquake precursors in the prediction of earthquakes. Earthquake precursors include electric and magnetic fields, gas emissions, groundwater level changes, temperature changes, surface deformations, seismicity, as well as animal behavior. A number of instruments can be used to monitor and detect some of these precursors. Radon gas counter is used to detect radon gas since the amount of this gas dissolved in groundwater usually increase before earthquake. A creep monitor is used to monitor small movement along a fault. A laser reflector is also used to detect movement along a fault. Tilt meters are highly sensitive instruments used to measure ground tilt near faults. Magnetometer is used to detect slight changes in the Earth's magnetic field. Leveling survey is used to detect pre-earthquake ground movement. Animals have a sixth sense that allows them to pick up signs of impending earthquakes. Animals like rat, weasels, snakes, and bees usually leave their home for safety. Horses start to stampede. Chickens stop laying. Dogs bark wildly. There is often mass migration of frogs and toads, and birds usually take to the air. Disaster prediction is very important, but it is not the only thing involved in the management of disasters. Disaster management is a continuous process divided into phases. This diagram shows the phases of the disaster management cycle. The cycle illustrates the ongoing process by which governments, businesses, and civil society plan for and reduce the impact of disasters, react during and immediately following a disaster, and take steps to recover after a disaster has occurred. Let us look at the four stages or phases of the disaster management cycle. Stage one is mitigation, which is the phase where efforts are made to try to prevent the event or at least minimize the result. Stage two is preparedness, which is a phase of planning how to respond to the hazard. Stage three is response, which is the initial action taken as the event occurs. Stage four is recovery, which refers to effort to restore life to normality. At the mitigation stage, where measures are aimed at preventing or reducing the impact of the hazard, two categories of measures are usually carried out. These are structural and non structural measures. Structural measures involve changing the physical characteristics of a building or an environment to curb the effects of a disaster. It measures, sorry, the measures involve construction to reduce or avoid impacts. It includes the designing of new structures as well as the retrofitting of old structures. Non-structural measures are those measures that use knowledge, practice, and or agreement, especially through policies and laws instead of physical construction. So what we're going to do now is just to zero in on some of the structural measures. Structural measures used to mitigate against flooding include the elevation of buildings, flood-proofing of existing buildings by waterproofing existing walls, building levees and sandbags to contain rivers, altering river channels through straightening, widening, and deepening them. It also includes relocation of any existing building to new sites outside of the disaster zone. Along the coast, structures such as sea walls and artificial reefs are built to significantly reduce wave energy. Some structures, such as groins, breakwaters, and artificial headlands, are built along the coast to enhance deposition, which in turn help to prevent coastal flooding. Natural features such as gravel bars and sand dune systems, as well as mangrove forests, have a buffering function and therefore provide significant protection against storm waves. This means that protecting these features, these natural features, is important. Structural measures used to mitigate against flooding. All right. So now let us look at structural methods used to mitigate against volcanic eruption. Now, for volcanoes, the safest strategy during a volcanic eruption is actually evacuation, since buildings are easily destroyed during a volcano. However, when reaching to a safe location takes longer than the available time, a pedestrian bridge can be constructed to expedite evacuation in locations where rivers can slow down movement. Existing facilities can be replaced with new facilities located well outside of the disaster zone. For earthquakes, structural measures include improving the building elements that hold up a building and resist lateral forces from earthquakes. These include the foundation, the floors, the roofs, the columns, and the walls. Existing buildings with substantial seismic deficiencies can be replaced with buildings that are more earthquake resistant. Replacement with a new building on a different site may also be best if an existing site is also subject to other natural hazards such as floods. Existing highway structures vulnerable to earthquake hazards can also be replaced or retrofitted. Bridges are now being designed to resist earthquakes. They have reinforcing bars with a metal alloy made from a mix of nickel and titanium, which will flex and snap back into their original shape when the earthquake is over. Now let's move on to the next phase, which is preparedness. The preparedness phase is an ongoing process in which people plan and train for what they will do in the event of a disaster. It is ongoing training, evaluating, and corrective action to ensure that the highest level of readiness is done. It includes earthquake drill, evacuation plans, and evacuation training. The response phase involves measures that are put in place immediately before, during, as well as immediately after the event. Plans made in the mitigation and preparedness stage are now put into action. First responders are sent out to assess the damage and make preparations for receiving the equipment and the volunteers who will rescue, evacuate, and provide medical attention. The recovery stage is a long stage. Long-term recovery may extend over years. Recovery includes restoring electricity, internet, water, and other essential services, repairing damaged roads and buildings, restoring jobs or creating new employment opportunities, offering counseling to those who are still traumatized, and so on. Even where all the structures and systems are put in place on a large scale, the way individuals respond is of vital importance to their survival. The government may create land use policies, but individuals must adhere to those policies. The government may give warnings of an impending disaster, but it is up to the individuals to heed that warning. Likewise, the government may provide relief funding, but it's up to the individuals to apply for those funding. There are some things that cannot be done at the community or government level, and so individuals must take responsibility to protect themselves and their families. How individuals respond is dependent on a number of factors. For example, the level of confidence in the warning system, the willingness of individuals to take heed to warnings depend on their confidence in the warning given. If past warnings have proven inaccurate on a number of occasions, it may reduce people's confidence in future warnings. Instead, people may view the current warning as a false alarm. Perception of the hazard is another factor. How people perceive a hazard will determine how they respond. If they consider that it will only cause temporary discomfort, they may be willing to take the risk or tolerate it. If, however, they view that it will take their lives, they may be more willing to respond more effectively. How they perceive the event is often based on their previous experience of the hazard. Thirdly, alternatives. If people consider alternative measures besides those suggested by officials, and those alternatives seem to suit them better, they may decide to ignore the official measures and go with the alternatives instead. Another factor is personality. People have different personalities. While some people are very cautious, others are risk takers. They actually get excited at the thought of danger. Okay, so this is where I stop. I hope that it was of benefit to you. Continue to support my channel by liking this video, sharing it with a friend, and subscribe.